everyone, welcome to the second part of the videos. In this video we will be exploring the 2D colliders, 2D rigid bodies, and 2D effectors, and how we can use them to create our game levels. First, let's talk about what a collider is. A collider is a bound that defines where the object has a physical property or a triggerable event. Let's take a look at it. There's plenty of different types that we can explore. As we can see, the square has basic components, and what we're going to do is create a new one that's going to help us define its physical properties. We can click add, and we're going to type in collider 2D. As you can see, there are multiple different types of colliders that we can attach to this object. We're going to start with the box collider. In our box collider, there are many options that we can click and change. We'll start with the most important one, the size of the object. When we increase it, you can see the border expanding around the sprite. This actually creates the physical properties that the object will interact with. So if this circle was to touch the square, it would actually hit this green border rather than the actual sprite itself. Other options that are important to note are the trigger. This will change it from a physical property to a triggerable event. That means if something enters it, you can create a code that will react to it. A good example of it is a coin. If a player walks into the coin will disappear and will increase the player's coin counter later on. We're going to be using the effectors. These are used for physical properties. We'll explore this further. Composite is collecting all the different colliders on the object into one big collider. We'll be using this later in tiles. And one more important thing to look at is the edit collider. This gives you access to control the collider by dragging these nodes and expanding it or shrinking it in whatever way you'd like. Let's reset this guy back to its original state. Next, let's take a look at another collider type. As you can see, there's more. We have capsules, circles, composites. Let's make a circle for our circle. This one uses a radius to control its size. Let's make it smaller. So in this situation, if this circle touches something else, a part of the sprite will be overlapping the other sprite as the collider is inside. Lastly, let's take a look at a polygon collider. Since a triangle is neither a square or a circle, a weird shape has to be created for it. That is called a polygon. Polygons are created by edge colliders. If we click edit collider, you will notice that there are edges or lines, and you can actually move them in any way or shape you like, or you can even add multiple nodes to change the way the object will look. Let's leave it at this pentagon shape for now. One last thing to mention is that any object can have a collider. It doesn't have to have a sprite. So right here, we've created a box collider on this object. This is our invisible wall, and it will be interactable as if it was anything else. Now, to test out rigid bodies, we would like to have some kind of floor. So let's create a copy of the square. Let's move it down here. Let's change the color for visuals and make it larger. As you can see, the box collider adjusts with the scale of the object. So 1:1 is actually referencing whatever the scale is of the initial object. Now, if we were to play the game now, nothing will happen. There is no physics attached to any of the objects yet. For that, we will create a component called Rigidbody. Make sure it has the 2D suffix, and this will allow it to have physical properties. Firstly, let's talk about body types. There are 3 body types for 2D objects. Dynamic, which means anything that comes in contact with it will have a physical reaction on it. Kinematic, which means that you can control it with code, move it around. And static, that will mean it's a solid object that can't be moved or pushed. Mass is used to define which object is bigger and therefore has more force when the 2 objects interact with each other. Linear drag and angular drag control how fast the object picks up momentum through the air, for example when falling or slowing down. Gravity scale is the multiplier of the basic gravity that's inputted in Unity. If you were to go into Unity settings, you can change the gravity basis. We don't really need to worry about collision detection, sleep, and interpolation at the moment, and I would like you to focus on the constraints. Constraints allow you to freeze the object from moving in a certain direction or rotating. For example, when we're going to make our player, we don't want them to tip over every single time they touch a physical object, so we'll turn off the rotation on that. So let's test out this rigid body and see what happens. As you can see, our object fell and interacted with the collider on here and stayed there. Let's add a collider to our circle and move our objects around to create a more interesting interaction. First, let's take our triangle and place it here. As we talked about, even though the sprite is here, the collider will actually make the square either fall left or right because of this point. Next, let's move our box invisible wall and place it here. And let's take our circle and place it on top of the square, adding a rigid body to it as well. Let's see how that simulates. Before we move on to the effectors, let's talk about this material that can be placed in a box collider or rigid body. The material controls the friction and bounciness of the object. To place a material in here, we first have to create one. I'm currently in the Assets Physics Material folder, and I'm going to create a new asset that will place in here. So I can right click inside the project view, or I can click on the plus button here. I'm going to right click. I'm going to go to create 2D physics material 2D. And you can name it or whatever you want. I'm going to leave it with the new physics material name. You will have two variables that you can control, the friction and bounciness. Friction is how much force is presented when two objects collide. So if you have an object sliding across the desk, an object with a higher friction will stop faster than an object with a low friction. Bounciness is a bit easier to explain. It's how bouncy the object is. So if it hits another object, it will bounce off of it. To test this, let's make our bounciness 1 and leave our friction as is. We're going to add our new physics material here. We can do that by dragging, or you can click the circle and it will show all the physical materials in your game. Let's click play. And as you can see, we now have a bouncy square. Now that we have an idea of how the physics system works in Unity, let's expand on it by using effectors. Effectors allow you to give additional force properties to an object that will be exerted onto a rigid body. In this situation, we're going to place effectors on our floor, which will then exert forces on our white square, making it move, jump, or even float. Let's start by typing effector. Effectors are only in 2D. You don't need to worry about having a 3D effector. We're going to start with a surface effector. The surface effector will exert a force on the object, pushing it right or left of the x-axis, given the speed. Currently the speed is positive, but if we make it negative, let's say -3, the square will move left of the box. As you can see, it has options such as friction and bounciness, and you can choose to ignore or use those properties as given by your physics material. Before we do anything, we have to address the warning sign. Right now it's telling us that you need to click the effector toggle on the box collider to utilize this force applier. And now the system will work. And as you can see, our box got thrown off the edge. Let's try a different effector. We're going to add a buoyancy effector. This will make the object act as if it's water. First, let's address the warning. It's telling us that it needs to be a trigger. That means there is no physical property to this box. When our white box hits the black one, it's going to fall through. But if we make the settings correct, the box will actually hit the black water and float on top of it. In here, you can see the different properties that the buoyancy effector has. First, density is how dense the object is. Denser objects will fall through, lighter objects will float, and objects around the same density will just hang in suspension. Surface level controls where the top of the water is. We can leave it here. Dampening defines how much force is exerted on the object when it first hits, so it will slow it down. Let's make this around 20. And then flow uses similar abilities as the surface, so we can actually make it move in a direction. So when our box hits it, it will float down below a bit, it will bob up, and then it's going to start moving bright as all of that is happening. Let's test it out. So now our box is on a journey through a slow moving stream. Let's go over another type of effector. We're going to use the area effector. Area effector, like the buoyancy one, uses a trigger, so this is not a physical object. Area effector exerts a massive force in a given direction. So right now it's going to shoot this white box 10 to the right. The force angle is 0 and it reflects wherever the x-axis is pointing. So let's make it 90, so it shoots directly upwards. And let's make the force 300, so it shoots very far up. As before, we saw the dampening. You can change it to make sure that the box doesn't fly too much down when it hits. Let's test this out. And as you can see, our box is now happily bouncing off of that effector. Let's increase the force slightly, and we're gonna create a new platform. Let's copy this one. Let's move it above the white box, and we're gonna create a new effector that's gonna be attached to it. We're gonna use the platform effector. The platform effector allows you to move through one side while having the other side be a physical object. In this case, the upper side, reflected by this arc, is a physical place where our box will be able to stand. Meanwhile, anything below it will be able to be passed through easily. Very useful for 2D platforming games, and one we'll be using in our game. As you can see right here, the surface arc is defined by 180, which is shown here, and you can make it look like anything you want. Before we test it out, we gotta address the warning. Platform effectors are not triggered. They are physical objects, so we remove the trigger. And let's test our new effector. And as we saw, the box flew up above and now is safely landed over here. There's one more effector that we're going to go over, but it acts very differently from the others. To do that, we have to have a little bit of setup. So first, we will have two objects. One is a square and one is a circle. Both will have a collider. The square will have a square collider. The circle will have a circle collider. And both of them will have a rigid body with a gravity scale of 0. That way they don't fall. That way they both just hang out there while the effector does its job. So let's first start with the square. We're going to add an effector, and it's going to be a point effector. Point effector allows two point effectors to interact as a system. Its image is a magnet. That's because its job is to use forces to attract or repel objects from each other. In this situation, we're going to have the square attract the circle towards it. Negative numbers means attract, while positive numbers mean repel. Let's first deal with the warning sign. We have to make the box collider triggered and an effector. We're good on that front. We're going to be using the source, which is the rigid body, to attack the rigid body of this circle. Force mode is set to constant. It can be inverse linear or inverse squared. It's just the rate of change at which the object is pushed or pulled from each other. Another thing we have to set in mind is that the box collider in this situation needs to be extended. This is the area where the effector will have effect on other objects. Next, let's go to our circle. We're going to also create a point effector here. Let's resolve the warnings. And we're going to give this one a force of 0. That way it doesn't put any forces on the square. It only gets affected by the square. Let's test it out. And as you can see, the circle is now rotating around our square. If we go to our square and we change our force magnitude to 10, it gets repelled and is gone forever. That's going to conclude this part of the lesson. Next time we're going to go over sprite sheets and tile maps. And once we cover all of that, we'll be ready to put together our game.